You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine handing the keys to your entire production database to, like, a hyperactive intern.
Oh boy.
Right. And this intern works at the absolute speed of light, which sounds great, but unfortunately they possess the historical context of a goldfish.
That is a terrifying way to put it, but honestly, it's highly accurate.
Yeah, and that's essentially what a lot of developers are accidentally doing right now with autonomous AI agents. Welcome to the deep dive.
I mean, we are handing over this immense power to our tools, but we're quickly realizing that speed without context is just, well, it's a recipe for disaster.
Exactly, and that tension is exactly what we're exploring with you today. Our stack of sources comes from an incredibly dense snapshot of the developer world from late June 2026, specifically the TLDR Dev newsletter.
It's a packed one, too.
Oh, totally. We're looking at everything from Meta dropping a colossal open-source design system to the 35-minute microscopic journey of a single math equation on a GPU.
Which is wild.
Right. All the way to developers practically begging to lock themselves in windowless rooms just to escape their smartphones. Our mission today is to just cut through that information overload.
Because it really is an ecosystem caught between a ruthless demand for automated, infinite scale, and then this very human need to actually understand the systems we're building.
Okay, let's unpack this.
Yeah.
Because before we jump into rogue AI or
Yeah.
bare metal server architecture, we have to start at the surface,
Huh.
the interface layer.
Right, where the user actually clicks the buttons.
Exactly. Because developers are really struggling to manage the sheer complexity of the UI right now. Take React, for example.
Yeah, React is a perfect starting point. I mean, for a long time, React hooks were the absolute gold standard for managing state.
And by state, you mean like the data your app is currently holding on to.
Right, like whether a user is logged in or what's sitting in their shopping cart. Hooks are brilliant when you are managing that state locally, really close to the actual buttons the user is interacting with.
But the sources are pointing out a pretty massive scaling problem. What happens when your app grows and suddenly, a dozen different components on totally different pages all need to know what's in that specific shopping cart?
Well, that's exactly where hooks start to break down. You end up doing something developers call prop drilling.
Prop drilling. It sounds painful.
It kind of is. You're basically passing that data up and down the component tree over and over.
Yeah.
You pass it to a parent, then a child, then a grandchild, until your code base looks like a completely tangled ball of yarn.
And if you change one thing, everything re-renders, right?
Exactly. It becomes completely impossible to maintain, which is why we are seeing this massive architectural shift toward dedicated state managers like Zustand.
So how does Zustand actually untangle that yarn? Does it just bypass the tree?
That's exactly what it does. It pulls that shared state entirely outside of the chaotic React component tree. It creates a dedicated global store.
Okay, so it sits on its own.
Right. And then components just subscribe to the specific pieces of data they actually need, rather than forcing you to pass it down a massive, clunky chain. It's really about drastically reducing the cognitive load required to build complex interfaces.
And speaking of cognitive load, Meta just dropped something that feels like, well, an attempt to solve interface complexity on an absolute enterprise scale.
Oh, you mean Astryx?
Yeah, Astryx. They finally open sourced their internal design system. And they supposedly spent 8 years building this thing.
It's massive.
It currently powers over 13,000 applications. 13,000.
The scale really is staggering. I mean, they released over 150 accessible components right out of the gate. But what's revolutionary here isn't just the size of the library, it's the underlying philosophy.
Because it features what they call open internals, right? With no styling lock-in.
Exactly.
Which is wild to me, because usually, when a giant tech conglomerate hands you a design system, it's a completely walled garden. You have to build it their way, using their exact buttons. So why open it up?
Well, it's because of who, or rather what, is doing the building these days. Meta designed Astryx with this collaborative API specifically meant for both human developers and AI coding assistants.
Wait, they built a UI library specifically for AI to use?
Yes. By standardizing the underlying architecture so strictly, an AI can parse the building blocks just as easily as a human developer can. They are standardizing the interface layer to make AI vastly more effective at writing UI code.
But wait, there is a massive pushback happening against standardization right now, specifically over in the Apple ecosystem.
Oh, the Squircle Rebellion.
Yes. One of our sources highlights this movement called Free the Icons. Developers are actively rebelling against Apple's macOS design guidelines, specifically those uniform squircles.
Ah, yes, the squircle. That perfectly mathematically rounded square shape that Apple basically forces every single app icon to adopt.
Right, and developers are arguing that forcing every icon into the exact same shape is just terrible for human usability.
It really blends together.
It does. They are demanding a return to distinct, very jagged shapes, which brings up a really fascinating contradiction in the dev community right now.
Oh, so?
Well, it's like developers want a perfectly organized, uniform toolbox like Astryx, so every tool behaves exactly the same way under the hood. But then they want to paint the handles of all those tools wildly different colors and shapes like the macOS icons, so they can actually find them in a hurry.
What's fascinating here is that those two seemingly contradictory desires are actually driven by the exact same psychological need.
You really? How?
Think about it. Zustand and Astryx reduce the cognitive load of building software. We absolutely crave uniformity in our code architecture so our brains and our AI assistants don't have to reinvent the wheel every time we make a button.
Okay, that makes sense. But what about the squircles?
The Squircle Rebellion is about reducing the cognitive load of navigating software. When everything is a uniform squircle, the human brain has to work incredibly hard to parse the visual information on a crowded dock.
Because everything just looks like a smooth little tile.
Exactly. We need strict predictability in our code, but we desperately need distinct visual landmarks in our user interfaces.
That distinction makes a lot of sense.
Huh.
But if we are standardizing tools like Astryx specifically so AI can build alongside us, we kind of have to ask the uncomfortable question.
How capable is AI at actually writing our code right now?
Yeah, I mean, is it really ready?
The reality in the trenches is highly polarized. One source from a developer deeply embedded in HTMX describes their reliance on AI as strictly 50-50.
Meaning 50% of the time it's genius and 50% of the time it's useless.
Pretty much. They say it's phenomenal for generating unit tests or debugging isolated self-contained functions,
Sure.
but the moment you ask it for an architectural solution, it's a massive liability. They brought up a specific incident with the HTMX hyperscript parser.
What exactly went wrong there?
Well, a hyperscript parser is the thing that translates custom HTML attributes into actual browser behaviors. It's a really complex, historically nuanced piece of code.
Like full of weird workarounds.
Exactly. Full of legacy decisions that made sense 5 years ago but look totally illogical today. When the developer let the AI try to fix a bug in that parser, the AI suggested a fix that looked mathematically perfect.
Oh, I see where this is going.
Yeah, it would have introduced catastrophic technical debt because it completely ignored the historical context of the codebase. It required intense human intervention to stop the AI from ruining the entire system.
He goes right back to that hyperactive intern analogy we started with. The AI knows the syntax rules perfectly, but it doesn't know the culture or the history of your specific code base.
None of the unwritten rule.
Right. And this isn't just about technical debt either. It's costing real money. Another source broke down the unexpected spend of using Claude Code, and it's not what people think.
Right, because developers naturally assume they're blowing their API budgets on massive, long-running conversations.
Yeah, that's what I would assume.
But the actual drain is something they call session startup overhead.
How does that work? Why does just starting a session cost so much money?
Because an AI doesn't just wake up and instinctively know your project. Every single time you spin up Claude to ask even a quick question, it has to silently read and process a massive amount of data.
Like the configuration files and stuff.
Yes, accumulated config files, environmental context, project rules, and it reads all of that just to get to the starting line. That invisible context processing happens every single time, quietly draining your budget.
So the AI struggles with messy historical code and costs a fortune just to boot up. But then, and this is why I love this stack of sources, I read the source on formal verification, and it felt like I was reading about a completely different technology from a different dimension.
Formal verification is such a fascinating pivot in this discussion. Essentially, it is the process of writing rigorous mathematical proofs to guarantee with absolute certainty that your software will execute flawlessly.
Oh, bugs.
No bugs, no edge cases. Pure mathematical proof.
But historically, writing those proofs by hand is so painfully slow and expensive that nobody does it.
Right.
Unless they are building software for, like, base makers or space rockets.
Exactly. It requires highly specialized mathematical knowledge that most web developers just don't have. But right now, the cost of formal verification is plummeting.
Because of AI.
Yes, because while AI might stumble on messy historical HTML parsers, it is astonishingly good at writing mathematical proofs.
Here's where it gets really interesting. Look at this wild contradiction. If AI is suddenly advanced enough to give us literal mathematical certainty and formal verification,
Yeah.
why is it simultaneously stumbling so hard on an HTMX bug that it threatens to take down a web code base?
Because you have to look at the environment the AI is operating in. Formal verification is essentially pure math. It is a sterile environment.
Okay.
It has strict, logical boundaries and definitive right and wrong answers. AI thrives in bounded logic. But a 10-year-old web framework, that's messy.
Yeah, it's just a human disaster zone.
Exactly. It's full of implicit, unwritten human context. AI can generate perfect logic, but it cannot intuit unwritten history.
Well, we really need to figure out how to bridge that gap quickly,
Mm.
because the sources show we are actively moving away from AI that merely suggests code in our editor to autonomous agents that actually execute tasks on their own.
This is easily the most disruptive shift in the entire stack today. The sources highlight this explosion of local models, specifically Quinn 3.627b, being hailed as the new sweet spot for local development.
27 billion parameters running locally on your own machine.
Yes. Using execution frameworks like llama.cpp, you can run highly capable general intelligence locally without cloud costs. But the real game changer is combining a model like Quinn with tools like Craft Agents OSS.
Which was mentioned in the launches section of the newsletter.
Right. Craft Agents is an open source framework that allows that local model to connect to your external databases, hit live APIs, and automate multi-step workflows.
So you aren't just chatting with it anymore, you're literally giving it a job and walking away. Yeah. But the source from ingest includes a terrifying warning about doing exactly this. They explain what happens when one of these smart agents hits a tiny bump in the road, say a downstream API times out for half a second.
Right, the agent just acts on its basic programming. It retries the call, and if it fails again, it retries instantly.
Oh no.
Yes. Within seconds, your helpful little AI agent is hammering a fragile third-party API with hundreds of requests, driving your entire system straight into rate limit oblivion.
It's the sorcerer's apprentice. You know, with the multiplying brooms.
That is the perfect analogy.
Give it a tiny bit of magic, tell it to clean the floor, and suddenly the whole castle's underwater. How do we prevent these local models from accidentally deducing our own systems?
Well, Ingest points out that we desperately lack infrastructure maturity for agents, and the specific solution they mandate is called durable execution.
I need a breakdown on that. What does durable execution actually look like under the hood?
It means checkpointing every single step of an agent's workflow. Imagine an agent has a 10-step job. If it fails at step 6, a standard script might crash and then blindly restart from step 1.
Which duplicates work and hammers the servers.
Exactly. Durable execution pauses the process, securely saves the exact state of the job like a save point in a video game, and when the issue is resolved, it resumes only at step 6. It guarantees a step is never duplicated.
That sounds essential. And the sources also heavily emphasized agent evils. Why is evaluating an agent so difficult?
Because most teams try to evaluate an agent by reading the log files after the job is already done.
Right, like looking at the wreckage.
Yes. But to score real outcomes safely, the actual guardrails have to live directly in the execution layer, running alongside the data. You have to evaluate the agent's decisions in real time before they execute, not just read the autopsy report.
Okay, so to support these 27 billion parameter local models and manage durable execution state across thousands of workflows, we have to look at the engine room.
The bare metal.
Exactly. We have to zoom all the way down to the bare metal of the hardware and then all the way out to infinite cloud infrastructure. Let's start small. Like microscopic. There's a 35-minute deep dive in the sources just explaining how a GPU adds two vectors together.
It is a phenomenal breakdown of a CUDA kernel, because to understand why we can run massive AI models, you really have to understand the orchestration happening at the silicon level.
Stop right there. I know what a CPU and a GPU are, obviously, but what exactly is a CDA kernel, and why does it take 35 minutes just to explain simple addition?
Well, a kernel is just a function that runs on the GPU. But the complexity comes from the handoff. Your CPU is essentially the host, and your GPU is the device.
Okay.
The CPU compiles the code using a tool called NVCC, allocates the memory, and then has to tell the GPU what to actually do. But it doesn't just hand over a simple text file. It pushes commands through something called a push buffer.
Okay, let's use an analogy here because I'm getting lost.
Right.
Let's say the CPU is the head chef in a massive restaurant kitchen, and the GPU is an army of, say, 1,000 line cooks who can only do one specific task, but they could do it perfectly simultaneously.
Yeah.
So the head chef isn't cooking the meal, they're writing the orders and sliding them down the ticket rail. Is the ticket rail the push buffer?
That is an excellent way to visualize it. Yes, the push buffer is the ticket rail. And on that rail, the head chef attaches something called QMD, Q metadata.
And what does the QMD do?
QMD is the highly specific formatting of the ticket. It tells the kitchen exactly how to group the line cooks to execute the order. The GPU then organizes those cooks into warps.
Warps?
Yeah, warps are groups of 32 threads that execute the exact same instruction at the exact same time. If the order is to chop carrots, 32 cooks raise their knives and chop in perfect, synchronized unison.
That's a lot of carrots.
And the memory access is heavily optimized, so none of the cooks bump elbows while grabbing those carrots from the fridge. It is an absolute masterpiece of parallel computing.
That is incredible micro-level optimization. But then we zoom out from the GPU to the macro level, looking at where all this process data actually goes once the cooks are done.
Right, the storage layer.
The sources highlighted FocusDB, which is built on Cloudflare durable objects. They market it as having bottomless storage.
Right.
But how do you actually find anything in a bottomless database without it taking an eternity?
That is the magic of FocusDB. It achieves strong consistency at infinite scale using extremely rigid partitioning, specifically hash keys and range keys, combined with topology encoding.
You're going to have to explain those to me. I need another analogy.
Think of a hash key as the label on a massive filing cabinet. It tells the system exactly which physical cabinet holds a specific user's data.
Got it. And the range key?
The range key is how the files inside that specific cabinet are organized, maybe chronologically or alphabetically, so you can grab a sequence of elements instantly without scanning the whole cabinet.
And topology encoding, what is that?
Topology encoding is essentially a decentralized map. It ensures that if a user in Tokyo is requesting their data, FocusDB physically moves that specific filing cabinet to a server located in Tokyo. It optimizes the physical distance the data actually has to travel over the wires.
So what does this all mean for data quality? We had an entire source dedicated to data quality fundamentals, breaking it down into granular quality, aggregate quality, and fitness for purpose.
Right.
If we have this insane CUDA optimization, but we dump it into bottomless storage, doesn't infinite scale just encourage us to be sloppy? Like, just save everything, we have infinite room.
If we connect this to the bigger picture, infinite scale absolutely does not mean structureless scale. It's actually the opposite.
Really?
Look at FocusDB. It only survives because of its rigid hash and range keys. That aligns perfectly with the data quality framework. Granular quality, making sure individual data points are correct, is what makes your hash keys work.
Oh, I see.
Aggregate quality is your range keys. And fitness for purpose is the actual business outcome. Infinite scale requires far more rigorous architecture, not less. Without those strict frameworks, bottomless storage just becomes a bottomless garbage dump that yields zero business value.
Oh, okay, my head is officially spinning.
We covered a lot of ground.
We really did. We've traveled from the cognitive load of massive interface design systems to the dangers of autonomous AI agents taking down APIs, down to the microscopic warps of a GPU line cook, and out to the hash keys of a bottomless database.
It's exhausting just saying it all out loud.
It is. So after all of this, how does the individual human developer, the person actually sitting in a chair staring at a screen, survive this ecosystem?
Well, the final pieces in our stack point to a growing cultural shift towards self-preservation. There is this great article titled Rebuilding the Computer Room, which argues that developers need to actively reject the modern convenience of portable devices.
Wait, physically, like going back to a bulky desktop PC?
Exactly, because laptops and smartphones brought computing into every single second of our lives, which resulted in constant, inescapable digital distraction.
You can never just leave work at work anymore.
Right, so the movement is about establishing a physically separate room in your house, a place where computing happens, and when you walk out the door of that room, you leave the digital world behind completely.
Creating physical boundaries. I love that. And we are seeing that exact same desire for boundaries reflected in network architecture, too. The Human-Centered Computing Foundation, the HCCF, is actively trying to launch a brand new top-level domain, .self.
Yes, the .self domain is entirely dedicated to self-hosting. It is a direct infrastructural pushback against the centralization of the web by massive tech giants.
It's like planting your own flag.
It's about drawing a line in the sand and saying, this specific infrastructure belongs entirely to me, and I control the servers.
Which ties perfectly into the final piece of our stack today. Personal branding. The source insists that building a brand in the modern dev community shouldn't be about algorithmic hacks or engagement bait on social media.
Thankfully.
Right. It says it has to be rooted in deep reflection on personal values, maintaining absolute integrity, and genuinely helping others. It's presented as a counter-movement to the loss of authenticity in the automated workplace.
It really is a search for meaning and human connection in a landscape that feels increasingly sterile and machine-generated.
I hear that, but I have to ask the cynical question here.
Go for it.
Look at the irony of our journey today. We started by talking about Meta, literally one of the largest, most powerful corporations on Earth, powering 13,000 apps with a standardized design system so AI can write our code faster.
Yeah.
And we ending by talking about hiding in a physical computer room, buying a .self domain to escape our smartphones, and focusing on our authentic personal values. Is this sudden push for authenticity actually genuine altruism?
That's a tough one.
Or is it just a massive defense mechanism? Like, is it the only way we can figure out how to stand out in a tech world that feels completely swallowed by autonomous agents and infinite scale?
This raises an important question, and honestly, your cynicism is entirely valid. It likely is a defense mechanism. But here's the synthesis. Whether it is genuine altruism or just a desperate survival tactic against automation, the necessary remedy for our current level of digital saturation remains exactly the same.
Boundaries.
Boundaries. We are seeking architectural boundaries with the computer room, infrastructural boundaries with the .self domain, and professional boundaries through authentic personal branding. We're desperately trying to build walls to protect the human element from the infinite scale of the engine room.
That is an incredibly powerful way to look at it. We really covered some intense ground today. We explored how Zustand and Astryx are trying to tame the interface layer. We navigated the incredibly dangerous waters of rogue AI agents and the critical need for durable execution.
Don't forget the GPU line cooks.
Right? We zoomed all the way down to the bare metal of NVCC and CUDA warps, and we ended on the deeply human desire for a quiet room and a little bit of digital sovereignty.
The technology stack is expanding in every direction simultaneously. Down to the microscopic silicon, out to the bottomless cloud, and forward into autonomous agency. The challenge for you as a developer is figuring out exactly where your human context fits into that massive expansion.
Exactly. So, to you listening right now, take a hard look at your own workflows this week. Where are you relying too heavily on an AI sorcerer's apprentice without any durable guardrails to catch the mistakes? And more importantly, where in your life do you need to rebuild your own digital boundaries?
It's worth thinking about.
Definitely. I want to leave you with one last thread to pull on. We talked about how AI is getting astonishingly good at formal verification, giving us mathematical certainty in our code.
Right.
And we talked about deploying self-correcting, durable AI agents via craft agents to handle our tasks. If we actually perfect that, if the agents can write the mathematical proofs and run the entire system flawlessly without us,
What happens then?
maybe the computer room of the future isn't a physical room we retreat to so we can focus on work. Maybe it's a digital containment zone we lock our AI inside of to do the work so we can finally go outside and figure out what our authentic selves actually want to do with all that free time.
Now that is an amazing thought.
Keep digging deep, stay curious, and we will catch you next time.
Spoken Tech for your ears.